Hello everyone, welcome back to my trigonometry classes. In this section, we're going to talk about how to convert the degree to the radians. So, do you remember the circumference of a circle? So now I have a circle, and the circumference is equal to 2 pi r. Think about it. If I divide it by r on both sides, so I have a c, the circumference over the radius is equal to 2 pi. So that means 2 pi is equal to 3.14. So 2 times 3.14 is equals to 6.28. So that means if I want to divide the circle by the radius, I will get 6.28 section or units of a radius. So now we have the first, and then we divide another one, the second, third, 4, 5. Oh, okay. I need to spread out a little bit more since this is a bigger circle. First, oops. So this is the first part. Second, third, 4, 5, 6. And this little small section is going to be another 0.28. So this is how we consider a radians. So that means when the total is 2 pi, when c divided by r, the ratio is going to be the radians. So in this case, we can think about that the 2 pi radians is equal to 360 degrees. That's the angle. That's how we converted the radians to angle, because the total measure of a circle is 360 degrees. So that means for the whole radians, which is 2 pi, is going to equal to total 360. Now, if we simplify it, we divide it by 2 on both sides, I will get pi radians equals to 118 degrees. You divide by 2 on both sides. Or if you want to divide it even more, divide it by pi on both sides, so that, which is 3.14, then I have 1 radians is equal to 57.3 degrees approximately. What does that mean? So that means this angle, each of these radians angle in this part is 57.3 degrees. But you don't need to memorize that. All you need to memorize is this part. 2 pi, because the circumference is equal to 2 pi times the radius. So in this case, 2 pi radians is equal to 360. So what's the difference between radius and radian? So a radius is the distance from the center to the side on the circle, and the radian is a unit of an angular measurement. So another way to view this question is 2 pi is equal to 360 radians. Another way to do is one rotation. That means you rotate it 360 degrees. Sometimes they call it one rotation. Also equals to 360, right? If it's 360, that means it's equals to 2 pi radians. And then you can also divide it by half. so that you can get half a rotation, which is 180 degree, is equal to pi radians, which is 1/2 rotation is equal to 180 or pi radians. So all of this is just come from one rotation equals to 360, and then we can keep going, divide another half, which is 1/4 of a rotation, is equal to 19 degree, or 1/2 of the radians. Okay, so this part so far so good. So two things you just need to remember: 2 pi radians equals 360 degree, one rotation, which is 360. I'm going to cross that, which is one rotation also equals to 2 pi radians. Now, exercise. So 13 degree, how do I convert the degree to radians? Equals to how many radians? Well, do you remember that at the beginning of this section, we have a little bit review on the unit conversion. So in order to convert that, we need to know the conversion factor. So we want to convert the degree to the rotation. Now we need to look at the radians, the degree to the radians. So we need to know what's the relations. So we know that for every 2 pi radians is equal to 360 degree. So that means if I want to get rid of the degree, our conversion factor, I want to write down the degrees in the denominator. So that means I have 360 degree, and then on the top will be the 2 pi radians. Remember, radians is the units. Degree and degree cross cancel, right? 13 and 360, the common factor is 13. So I can divide it. So you have 120. So that means I have a 2 pi radians over 120. Now we can continue to simplify it. So this is 160. So that means 13 degree after I convert it to radian is equal to 1/6. Oh, I forgot to divide it by that. Should be 12. It's equal to 1/6 pi radians. Sometimes you will see in the exercise that they don't write down the unit radians. They just write down 1/6 pi. That also works. Just want to remind you. Now, let's do more exercise, such as how do I convert 45 degree to radians? Again, I have 45 degree times the conversion factor. For every 2 pi radians is in 360 degree. So that's it. And now degree and degree, they can cancel each other out. And then 360 and 45, what's the common factor? Well, the common factor also to be, we can try start with 5, divided by 5, I got 9. So here I have 52. Oh, sorry, it's 72. 72. Now, so I have a 9 times 2 pi radians over 72. But 72 and 9, they also have a common factor of 9. You can divide it by 9. So here is 8. So I have a 2 pi radians over 8, because the degree already cancel. Now, 2 and 8 common factor. 2, so I have a pi over 4 radians. So that means 45 degree equals to pi over 2 radians. Okay, let's do another one, the opposite. How do we convert the radians to the degree? For example, if I have a 5 over 6 pi radians, And I want you to convert this to a certain degree. So now the conversion unit has to be flipped because I want to get rid of the radians, so that means the degree needs to be on the top. So for every 360 degree, I have 1 radian. Oh, 2 pi radians, sorry. Now, radians and radians cancel. Pi and pi, they also cross cancel. Now, simplify it. We can do step by step. If it's too messy, I have 5 times 360 degree over 6 times 2. Now, let's continue. 360 and 6, they can cross cancel, so I have 60 on the top. So I have 5 times 60 degree. They didn't cancel the degree. You still need to keep the degree. Over 2. 60 and 2, they can cancel. This gives you a 13. So that means it ends up to be 150. So that means 5 pi 6 radians equals to 150 degree. Okay, let's do another one. Let's try the negative. Negative angle, we learned that before. We have a negative 3 pi over 2 radians. And now I want you to convert this to a degree. Now let's try to not put the radians since we're already familiar with the process. So I have negative 3 pi over 2 times the conversion units. Again, we want to get rid of pi or the radians, so that I want to write the radians in the bottom. For every 2 pi, we got 360 degree. Simplify it. Now pi and pi cross cancel. 360 divided by, let's do this, negative 3 times 360 degree over 2 times 2 is 4. And then 360 divided by 4 gives you a 19. So that I have a negative 3 times 19, so is negative 217 degree. So that means negative 3 half pi equals negative 217 degree. Remember that this is going to be a clockwise rotation. Negative 270 is what? It's a quadrantal angle, which is on the x-axis. Okay. Now there are some special one that I want you to remember. If you don't, that's okay, because we already learned that the conversion factor is for every 360 degree, we got 2 pi radians. So that's the most important things. But there's some very common one that I would like you to remember. Again, if you don't, that's okay. So first is this one, 0 degree. If the initial line and the terminal line are on the same one, they attach, there's no rotation, that's a 0 degree. If it's 0 degree, that means the radians also is 0. And then we have a 19 degree one. 19 degree one is half pi radians. If it's 100 degree, that gives you a pi. 217 degree, we just did it, which is 3 half pi. And what about 360 degree? If it's a 360 degree, it's not going to be 0 radians. 360 degree means they did a whole circle rotation and come back. This is equal to 2 pi. So that's different than 0, even though they are on the same terminal side. Do you remember what's that called? Yes, it's called coterminal angles. 0 degree and 360 degree is a coterminal angles. So another important one that you need to remember is the 14.5 degree, the 13 degree one. Let me use a different colors of pen. So this one is 13 degree one. 13 degree one is, the radian is pi over 6. If it's a 14 degree one, which is, it's going to be half of the 19 degree, which is half of pi over 2. So that gives you a pi over 4. And then 60 degree one, if it's 60 degree one, it should be pi over 3. So these are the ones that I want you to try your best to remember. If you don't, as long as you know how to do the conversion, you will still be good. But sometimes it will be faster to do the calculation if you know that. Okay, so let's do another example, such as how do I convert 120 degree to the radians. 120 degree, we don't know it right away, but you know that 120 degree is equals to 19 degree plus 13 degree. And from our chart, we know that 19 degree is pi over 2 and 13 degree is pi over 6. So when they add this together, it's equals to 4 over 6 pi. Simplify it, is 2 pi over 3. So 120 degree is equal to 2 pi over 3 radians. Okay, now let's talk more about what is a coterminal angles. So earlier, I already give you a little bit preview. Coterminal angle meaning that if the angle share the same initial and terminal side, when it's in the standard position, that we call it as a coterminal angle. If you have an angle in a standard position, you can find the coterminal angle by adding 360 degree or subtracting 360 degree. Does that make sense? Because they're coterminal, that means they make a circle back, they go back to that terminal side. Or if it's a radians, we need to add 2 pi or subtract 2 pi. It will get back to where they're at. For example, this one. And it's a 14.5 degree angle. In a standard position. It's very important that you are in the standard position to apply this one. So how do I find the coterminal angle? Well, one way to do it is we add in a 360 degree. So from the angle, so the angle ends in here, we add another 360 degree, then we get back. So that means the total length is going to be 14.5 degree at a 360 degree. That gives you the coterminal angle of the blue angle. So now I will get this one. I'm going to draw it smaller. Which is 405 degree is the coterminal angle of the 14.5 degree angles. Okay. So an angle reference angle is the smallest acute angle T prime formed by the terminal side angle and the x-axis. So that means to have the reference angle, we usually choose the smallest one, with the acute angles. In this case, the 45-degree one is going to be our reference angles. Okay, now let's get some exercise. How do I find the terminal angle? Oops. There are multiple terminal angles. There are multiple coterminal angles by any given angles, because you can keep adding or subtracting 360 degrees, right? Such as 45 degree and the 405 degree are the coterminal angle. Also, if I add another 360 on top of the 405 degree, I will get 765 degree. These are also coterminal angles with 45 degree,